Hello and welcome to the second week of Neon Dev Bootcamp. Last week we created an ERC24 SPL token on Neon EVM and tested it on Solana. This week we are going to concentrate on creating meme tokens, and we'll create an EVM memecoin launchpad on Solana through Neon EVM. We'll be using the skills we got last week. We'll talk again about the precompiled contracts and how to use composability requests. Also, we'll use our ERC24 SPL factory contract to deploy the memecoin launchpad and run the scripts to buy, sell, and graduate our token. In this project, we'll build a memecoin launchpad that deploys a liquidity pool in Radium DEX on Solana through Neon EVM's composability feature and custom libraries that generate Solana-specific instructions from our Solidity contracts. So with our memecoin launchpad, we'll be using a bonding curve and set a funding goal so that when the funding goal is reached, the pool will be created and the initial supply of LP will be locked. How a memecoin launchpad usually works, there are some conditions to be met and only then can you deploy a DEX pool. In our launchpad, we have defined a funding goal. For example, X amount of wrapped sols has to be collected as deposits, and only then there is a pool creation with a composability request to Solana. We have a bonding curve contract. You can decide to use any type of bonding curve formula because this is just a way to distribute tokens. So there is a fee that is going to be charged for each deposit. And when we deploy the contract, we define the factory because we need the ERC24 SPL interface for this token. We define the bonding curve, the wrapped sol address, and the fee percent that's going to be collected with each deposit. And the owner of the contract has permission to set the fee percent and to claim the fees. So here is a very important method for this contract, and this is a token sale. Initially, any public user on-chain has the permission to create a token sale. There are no restrictions, it's a public method. You define the name, symbol, and decimals to mint a token on Solana. And when the token is created, we change the state to funding. And once it's in funding state, anyone can decide to buy it. So this buy method is collecting the deposits, and in our token creation function, we already defined the funding goal. So when this number has been reached, there is a pool creation, and we stop the token sale by changing the token state to trading. After that, the token sale function doesn't work anymore. So when the funding goal is reached, we have an internal method which is create pool and lock liquidity. And inside of it, because there are all the deposits inside of the PDA contract, now we have to transfer them to the ATA accounts of the contract. And from here, we can go to composability requests and broadcasting it to Solana. So here we create a pool, and now we create a lock liquidity instruction. You get minted NFT, which represents this locked liquidity position, and then whoever holds this NFT can claim pending fees. These fees are generated in the pool from the traffic inside the pool. So for example, if I want to claim the fees immediately, I won't be able to do that because there is no activity yet. So I need to wait, for example, for any swap that's going to be charged with a small fee, and then this fee is distributed among the liquidity providers. And then we run the second instruction for locking the liquidity, and we are going to return the data on the pool ID, locked LP amount, and the NFT account which holds the liquidity position. And then we are going to return this data as events to pass them to the front end later. So lastly, we are going to collect the fees, and mind that there are two types of fees. First, the ones that the owner of the token sale can claim, and this type of fees is increased at each buy, and the ones that you can claim for each individual pool that is created. And now we are going to see what's going on in those on-chain libraries that abstract away the specifics of Solana for our contracts. Now let's take for example creation of a pool. With the libraries, a developer only has to request the create pool instruction, pass the tokens, their mint amounts, the start time of the pool, and the last are optional data to optimize the logic inside the instruction. But if you open the instruction, you'll see a lot of things that are specific to Solana. For example, this pool creation instruction requires 20 different accounts, and they have to come in a strictly defined order. For example, if we replace pool ID with token A, Solana won't accept this and immediately revert it. So this is one of the cases where on-chain libraries created by Neon come very much in handy, because they create these instructions for us. They know what kind of logic Solana expects and generate these instructions from our Solidity contracts. So, for example, as you can see, again, with these accounts, they aren't static. They have to be calculated dynamically, and also some of the accounts are signers, some are writable. So it's very difficult for an EVM developer to know all those things, and that's why it's very easy to do that with these on-chain libraries. So we are going to get more into each of those libraries in our later videos. Right now, you can clone this repo that I'm showing you with this project and test it yourself. Try to replicate this, changing some of the parameters, for example, for the bonding curve, for funding goal, or something small like this. And then we'll learn what exactly stands behind these libraries, so that you can create your own libraries and send your own composability requests for any use case you can think of. So now let's go back to the test script. Here first we deploy the bonding curve, then we deploy the memecoin launchpad, and then the first test is the creation of the token sale. So we defined a test token and the funding goal, which is 0.1 sols, and then we add the initial and the total supply of the liquidity pool. And at the end of the method, we check if the pool has been created. At the end of this test, we also create ATA accounts. Now remember, we saw before that before the pool is created, tokens are still in the PDA accounts of the contract, and to use these tokens in the composability feature, we have to move them to the ATA accounts. So here we make this transfer, but to be able to make this transfer, we first need to initialize the ATA accounts. So we go and create ATA accounts here. Then we have the first buy order that's not yet reaching the funding goal. We deposit 0.01 sols, which is 10 times less than our funding goal. And the second test is going, in fact, to reach the funding goal, because here we deposit even more than is needed. We deposit 0.15 sols. Let's open the transaction. Here we are passing 0.15 sols in the parameters, but the contracts know that it actually needs only 0.09 to reach the funding goal, because in the previous test we already deposited 0.01. So after the transaction is confirmed, we've also requested to get a receipt, so that on the front-end side we can fetch the pool ID, the locked amount of liquidity, and the NFT that holds the liquidity position. And if we open again the transaction, we'll see our pool creation right here. So this is the 0.1 sols we deposited and the 2000 tokens we passed as the initial supply for the pool creation. This is where we defined it in our contract. And this here is the fee we pay for pool creation. Each pool has a fee config which defines how much you should pay as a fee for a pool creation, and the config we use requires 1 sol. So this is what we are seeing here. So this transaction shows us the pool creation, and now here we see 1 token mint, which is actually the NFT you get in return for locking liquidity. Remember, we talked about getting the NFT position. And actually, we start earlier. Here we deploy the pool, we get these shares, and we burn these shares and get this NFT, which represents our locked liquidity position. And here, if we return to our tests, you can see that we also have a test for collecting pool fees. And as you remember, we can collect the fees only after there has been some activity in the pool, some sort of traffic. And to simulate this activity, we use a helper method called radian swap input to perform a swap with 1.001 sols as input amount, and we get in return a portion of token B. So this generates us a bit of fees, which we can collect with collect pool fees method, which is another composability request to collect the fees. And if we open the transaction, we'll see the fees we are collecting here, which is of course a very small amount of wrapped sols and of the token that we've created, since we passed a very small amount as input for the swap. And this is the end of our tests. So what we've done today is that we deployed our memecoin launchpad with the bonding curve token distribution logic. Then we tested how our memecoin launchpad interacts with Solana through Neon EVM's composability feature and its on-chain libraries. We've had a look what exactly one of those libraries does, and next time we are going to go into detail into those libraries and see how to create ones ourselves. But now what you can do is that you can replicate the creation of the memecoin launchpad on Solana via Neon EVM. And you can use our repository to do that. This would be a simple beginner's task, but still you will have to set up the environment and make sure that everything works. And if you're an advanced developer, then you can also change the token distribution logic and use a different bonding curve formula. And also you can create a UI for your memecoin launchpad and make it accessible for other people to use. Thank you so much for your time. I'll see you next time.